In order to successfully carry out Cramer's rule, you have to first know how to find the determinant of a 2 by 2 and a 3 by 3 matrix. So before we jump into Cramer's rule, I would like to quickly go over how to find the determinant of a 2 by 2 and a 3 by 3 matrix. A 2 by 2 matrix is perhaps one of the simplest ways to find the determinant. It's the simplest matrix you can have. So let's say you have a matrix A, B, C, D. Here you have your 2 by 2 matrix, and let's say it's A. A is the matrix. So to find the determinant of A, really all you have to do is you take these two variables and you multiply it together. So you get AD, and you minus it from the multiplication of these two numbers, minus BC. And that's it. It's so simple. That is how you find the determinant of a 2 by 2 matrix. Let's do an example. Say there's a matrix A1, which is equal to 2, 1, 1, 6. There you go. There's a matrix, right? The determinant of A1 is going to be 2 times 6 minus 1 times 1. Therefore, 12 minus 1, 11. 11 is the determinant of A1. Let's do another example. Let's say A2 is equal to 2, negative 4, 1, and 10. The determinant of A2 is equal to 2 multiplied by 10, 20, minus 4 multiplied by negative 1. Oh, sorry, 1 multiplied by negative 4. That becomes 20 plus 4, and that's 24. Now let's move on to a 3 by 3 matrix. Here is where it gets a little bit tedious. So I'm going to show you two methods. The first method is the tedious method, it's the long method, but it's the traditional method. You know, you'll find people doing this. But the second method is a bit of a hack. So let's go with method number 1. Say you have a matrix A equals to A, B, C, D, E, F, G, H, and I. This is your 3 by 3 matrix. What you have to realize is your first row is going to act as your variables, your leading variables in what you put down. So your determinant is going to follow the form of A minus B plus C. And these are all 2 by 2 matrices. All these. And how you find what goes in these 2 by 2 matrices is you always remove the first column. Oh, sorry, the first row. You always remove the first row, and you remove the corresponding column. So for the first one, what you're going to do is you're going to remove the first column, and you're going to remove the first row. So the first column is removed, and you're going to remove the first row, and you have this 2 by 2 matrix. And that is the 2 by 2 matrix that goes in this EFHI. Notice how it's positive, negative, positive, negative. That is how it follows. No matter how long your matrix is, it always follows as positive, negative, positive, negative, positive, negative. So if there was another column over here, you would put minus some D followed by some 2 by 2 matrix. But in this case, we don't have that. We only have this, and we're going to stick with this. Now let's look at B. So what goes in the position in this 2 by 2 matrix? So you cancel the first row, and then you cancel the corresponding column. So you have DF and GI. That is what goes in this DF and GI. And C, again, cancel the first row, last column, you have DE and GH. That goes in there. And now you already know how to solve a 2 by 2 matrix. So you have A, EI minus HF minus B, DI minus FG plus C, DH minus AG. And that is the determinant of A. On to method number 2 for solving a 3 by 3 matrix. Again, let's say we have the matrix A equals to A, B, C, D, E, F, G, H, and I. In this case, what you're going to do is you're going to quickly add the first two columns right next to your original matrix, right? And what you're going to do is you're going to multiply across diagonally like this, and you're going to add the multiplications like this. Just add these multiplications. That's step 1. So let's do that. So you have AEI plus BFG plus CDH. And you're going to minus this from the addition of the multiplication of these diagonals right here. Let's do that. Minus GEC plus HFA plus IDB. And that's how you solve the determinant of A. That is the determinant of A. I promise you, you can go back and compare this with the original determinant of A that we got from the previous method, from method number I, and you will find that it's the same thing. So again, what you have to do is just take these like diagonals, multiply these diagonals and add them as we have done here. And then minus it from the addition of these multiplications, HFA, IDB. And you will get the same answer. Let's follow this up by an example. First, we will do example number 1 using method 1. So again, we know that our leading variables are going to be 2, 0, and 6. Let's write them down. Positive 2 followed up by a 2 by 2 matrix minus 0 followed up by a 2 by 2 matrix plus 6 followed by a 2 by 2 matrix. Remember, cancel the first column, first row. That's how you get the first determinant. So it's going to be 2, 4, 2, 3. Cancel the second column and the first row again, you get the second 2 by 2 determinant, 7, 4, 1, 3. And you do the same with the 6, 7, 2, 1, 2. Let's solve it. You know that's going to be, so the determinant of A is equal to 2 multiplied by 2 times 3, 6, minus 2 times 4, 8, minus 0 into 7 times 3, minus 1 times 4, plus 6, 7 times 2, 14, minus 2. This is going to equal to 2 multiplied by negative 2, minus 0 into anything is just 0, plus 6 into 14 minus 2 is 12, and the answer is going to equal to 68. And that is the determinant of this matrix. Let's start. As you know, add the first two columns right next to the original matrix. Now, multiply diagonally. Multiply diagonally first. This way, and add these. So 2 times 2 times 3, 2, 2, 3, plus 0 times 4 times 1, plus 6 times 7 times 2. That is your first. Now, multiply diagonally this way. And you're going to be minusing the addition of that. So 1 times 2 times 6 plus 2 times 4 times 2, which is just 4 times 4, plus 3 times 7 times 0. That's going to equal to 2 times 2 is 4, 4 times 3 is 12, plus 0, plus 4, minus 1 times 2 times 6 is 12, plus 16, plus 0. And that is actually going to equal to 68. And that is the determinant using method number 2. And you can see how much quicker it is than method number 1. And I prefer using this. Let's finally move on to Cramer's rule. Cramer's rule is used to solve simultaneous equations. Traditionally, you could use substitution, you could use elimination, where you make one of the variables equal to each other and then you eliminate. However, in Cramer's rule, what you do is you create a matrix out of this. So you say A, C, B, D, and the results alpha, beta, and this is your matrix. And the variables you want to solve for are x and y, of course. Now this is your matrix. Cramer's rule states that if you take the determinant of this 2 by 2 matrix first, let's call this W. Let's call this W. Cramer's rule states that if you take the determinant of W, which is just AD minus CB, and then you replace this resultant column with the first column, so let's call that W1, you replace these columns, you get alpha, beta, BD, and you find the determinant of W1, which is alpha D minus beta B. You can find the value of x by taking that determinant of W1 and dividing it by the determinant of the original matrix W. So alpha D minus beta B divided by AD minus CB. Likewise, you can find the value of y by taking the resultant column and replacing it with the second column. So W2 is AC alpha beta. The determinant of W2 is A beta minus C alpha. So y is determinant of W2 divided by determinant of W. You get A beta minus C alpha divided by AD minus CB. Cramer's rule works for however many simultaneous equations you have. Let's say, for example, you have 3 simultaneous equations with 3 variables and 3 results. You're going to turn this into a matrix as well. So what you're going to do is you're going to be like A, B, C, D, E, F, G, H, and I, with their results alpha, beta, and gamma. And of course, you're going to find the determinant of this 3 by 3 matrix, let's say W. See, this is why it gets tedious, and that's why I showed you the shortcut method of finding the determinant of W, which is, you write it down, A, B, C, D, E, F, G, H, I. Write the first 2 columns, A, B, D, E, G, H. Multiply across, add. Is equal to AEI plus BFG plus CDH minus GEC plus HFA plus IDB. That's the determinant. And then you're going to take the resultant column and you're going to replace it with the first column. And that's just going to be alpha, beta, gamma, B, E, H, C, F, I. And this is going to be W2. That's W2. And you find the determinant of W2 as we have with W. And that determinant divided by determinant w is going to equal to the value of x. Likewise, you're going to do the same thing with y and z. I'm not going to do it here because it's long and tedious. I want to save time, but I will do two examples. One with a 2 by 2 simultaneous equation and one by a 3 by 3 simultaneous equation. Let's say you have this simultaneous equation pair. Again, we know the steps: 2, 4, 3, 8, 7, 12. We convert it into a matrix. Label the matrix A. What is the determinant of A? We know how to do this. It's 2 times 8 minus 4 into 3, which is equal to 16 minus 12, which is 4. So the determinant of A is 4. Now we take the resultant column and replace it with the first column. So we have 7, 12, 4, 8. And this we will label as A1. What is the determinant of A1? We know how to solve this as well. It's 7 times 8 minus 12 into 4. Let's just leave it at that. Therefore, our x value is the determinant of A1 divided by the determinant of A, which is 56 minus 48 over 4. And if you do this, 56 minus 48 divided by 4, you get x is just 2. That's the value. Now, from here, you could just solve y by substituting 2 into x and then, rearranging for y. But for good measure, let's take the resultant column and replace it with the second column. So again, 2, 3, 7, 12. And this is going to be A2. What is the determinant of A2? Well, it's 12 times 2 minus 7 times 3. And that is 3. So y is just determinant of A2 divided by determinant of A, which is equal to 3 divided by 4. And that is the value for y. Okay, now let's move on to a 3 by 3 simultaneous equation. So say you have a simultaneous equation with 3 variables and 3 results. So of course the first thing you're going to do is you're going to transfer this into a matrix, as we did with a 2 by 2 simultaneous equation. And you get this, and you label it as A. And then you find the determinant of A. And how do we do that? Well, we know how to do that. We multiply across diagonally like this, and you get the answer this, and then you minus it from the addition of these multiplications. And you get this. That's the determinant of A, of this alone. That's the determinant. Now, what you do is you take the resultant column and you replace it with the first column, as we have done here, and you label it as A1. And then again, you find the determinant of A1. How do you do that? Well, multiply across diagonally, as we have before, and add. Once you do that, you will get this. You'll get 40, because it's 0, and it's 0 over here. So 4 times 1 times 10, that's 40. Then you minus it from the multiplication of these diagonals, like we have with the 2 by 2. And you get this. Therefore, the determinant of A1 is just 280. So what's the value of x? Well, det A1 divided by det A, which is 140 over 59 if you do it. Okay, A2, you take the resultant column and you replace it with the second column. And we have done that over here again. A2 is this, and you find the determinant by multiplying across diagonally like this and adding it you get this, and then minusing the multiplication of this 570. And this is that. So A2 is 191. Therefore, Y is just det A2 divided by det A, which is 191 over negative 118. That is the answer. How do we do A3? Well, take the resultant column, replace it with the third column. And we've done that here, 273, 410, and 0110. And again, to find the determinant of A3, you multiply across diagonally like this, and you get this, and then you minus it from the multiplication of these, which is 3 times 10 times 0 is 0, 0 times 1 times 2 is 0, therefore 10 times 7 times 4, 280. You do this, you get negative 68, therefore Z is 68 divided by 118, which is 34 divided by 59.